Now, let yourself settle. Just like the dust motes dancing in a quiet sunbeam settle softly on a sill, feel the gentle weight of your own body, resting, supported, and as you rest, let your thoughts drift upwards, towards the great, wide sky that stretches out above us all. Think of it not just as emptiness or distance, but as something closer, something more like a vast and wonderful blanket tucked carefully around our world. A sky blanket, if you will, woven from air and light and mystery. Imagine this blanket. During the day, it's dyed the most beautiful shades of blue, sometimes pale and soft like a washed-out piece of silk, sometimes deep and vibrant like a field of cornflowers stretching to forever. Wisps of white cloud drift across it like downy feathers caught in a slow, gentle breeze, or perhaps like fluffy wool pulled thin in places. These clouds are part of the blanket, nestled within its lower folds. At night, the blanket changes. It becomes a deep, dark velvet, perhaps midnight blue or the softest black, and it's embroidered with countless tiny, shimmering points of light. We call them stars, these distant, twinkling diamonds sewn onto the fabric of the night. The moon drifts across it too, sometimes a bright, round pearl button, sometimes a slender, silver crescent, casting a gentle, milky glow. Whether by day or by night, this sky blanket is always there, always covering us, always holding us close. It feels immense, doesn't it? Stretching further than our eyes can see, arching over mountains and oceans, towns and forests, equally. It seems so simple, just sky. But like the most comforting handmade quilt passed down through generations, this sky blanket isn't just one single thing. It's made of different parts, different layers, each one special, each one with its own unique feel and purpose, all stitched together invisibly, seamlessly. Imagine running your hand over a familiar quilt. You might feel a patch of smooth cotton, then a slightly rougher square of wool, perhaps a soft velvety piece next to that. Each patch feels different, each has its own story, but together, they make the whole blanket warm and protective. Our sky blanket is much like that. It has layers too. Not layers you can easily see like different colored patches, but layers of air, stacked one on top of the other, reaching high, high above our heads, far beyond the highest clouds, far beyond the flight of the highest bird. These layers aren't rigid or stiff. They are made of air, gases so light and fine they swirl and mix at the edges, like colors bleeding into each other in a watercolor painting. Yet, each layer holds its place, performing its own quiet task in the grand design of keeping our world safe and comfortable. Think of them as different thicknesses, different textures within the great blanket. The part of the blanket closest to us, the layer we live in and breathe, is like the softest, thickest fleece lining. It's where the weather happens. The gentle rains that patter on the roof, the breezes that rustle the leaves, the fluffy clouds we watch drift by. It's the air that fills our lungs with each easy breath, the air that carries the scent of pine needles or damp earth or baking bread. This lowest layer hugs the earth snugly, keeping us warm, holding the moisture that gives us life. It's the part of the blanket we know best, the part we feel against our skin every day. It's our cozy corner of the sky. Above this familiar layer, the blanket changes. Imagine it becoming thinner, lighter, like moving from thick wool to fine silk. The air grows different up there. It's still part of the blanket, still protecting us, but its job changes. Perhaps this layer acts like a special filter, catching things, protecting the layer below. Think of it as a fine mesh within the quilt, almost invisible but doing important work. It helps to smooth out the temperature, preventing the earth from getting too scorching hot during the day or too freezing cold at night. It's a balancing layer, working quietly above the bustling weather below. Higher still, the sky blanket continues, becoming even more sheer, more delicate. Imagine layers like fine, shimmering gauze, almost transparent. Up here, the air is incredibly thin, barely there at all compared to the thick air we breathe down below. But even these wispy, high-up layers are incredibly important. They form a crucial part of the shield. They interact with the fierce energy pouring from the sun, absorbing the most harmful rays, like a special coating on sunglasses protecting our eyes. Without these high sheer layers, the sun's light would be too strong, too harsh for life as we know it. They act like a gentle parasol, filtering the sunlight, letting through the warmth and light we need, but blocking out the parts that could harm us. Think about how a real blanket keeps you warm on a cool night. It traps your body heat, holding it close, creating a pocket of warmth. Our sky blanket does something similar for the whole Earth. It holds onto some of the warmth from the sun, preventing it all from escaping back into the coldness of space. It keeps our planet at a temperature that is just right, not too hot, not too cold, a perfect gentle warmth that allows oceans to flow, plants to grow, and us to live comfortably. It's a climate-controlling quilt, woven with invisible threads of warmth and protection. And it protects us from more than just harsh sunlight or the cold of space. Imagine tiny specks of dust, little pebbles drifting through the vast emptiness beyond our world. Most of these are incredibly small, like grains of sand. When they approach Earth, they bump into the upper layers of our sky blanket. Even though the air is thin up there, it's enough. The friction, like rubbing your hands together quickly, causes these tiny specks to heat up and burn away, creating fleeting streaks of light we sometimes see at night. Shooting stars. Our blanket acts like a shield, catching these little cosmic crumbs, vaporizing them harmlessly high above our heads. It's a quiet, constant defense, happening mostly unseen, ensuring our world stays safe from this celestial dust. So, this vast expanse above us isn't empty. It's full of air, full of layers, full of protection. It's a multi-layered cocoon, spun from invisible gases, holding our world gently. Each layer, from the dense, weather-filled region near the ground to the thin, filtering veils high above, plays its part. They work together, a silent, cooperative system, creating the conditions we need to thrive. Think of the colors of a sunset or sunrise. Those beautiful oranges, pinks, and purples happen because the sunlight has to travel through more of the blanket's lower, thicker layers when the sun is low on the horizon. The blanket scatters the light, filtering out some colors and letting others shine through, painting the sky with breathtaking beauty. It's a reminder of the depth and substance of the air above us, a reminder of the blanket we are snuggled beneath. Even the simple blue of the daytime sky is a gift from our blanket. The gases in the air are particularly good at scattering blue light from the sun in all directions, making the whole sky appear blue to our eyes. Without this scattering effect, the sky might look black, even during the day, with the sun just a harsh, bright disk. That soft, familiar blue is the color of our protection, the color of the air holding us. Feel the air around you now. Perhaps a gentle coolness, perhaps just stillness. This air is the very bottom edge of that immense sky blanket. You are breathing it in right now. It connects you directly to the highest, thinnest layers, far, far above. You are inside the blanket, part of the world it shelters. It's a comforting thought, isn't it? To know that we are not exposed to the vast, cold emptiness of space, but are instead wrapped in this special layered covering. It's like being tucked into bed, with layers of sheets and blankets keeping you perfectly warm and safe. First, the soft sheet close to your skin, then perhaps a thicker blanket, maybe topped with a light quilt. Each layer adds to the comfort, the security. Our sky blanket does the same for our planet. Layer upon layer of air, each different, each essential, working together. We can't see these layers with our eyes, mostly. We see the clouds in the lowest layer, we see the blue color created by the scattering of light, we see the stars shining through the clearer layers above. But the distinct boundaries, the different temperatures and compositions, those are invisible to us from down here. Yet, they are as real as the different fabrics in a quilt. Scientists have studied them, measured them, given them names. But for now, Just hold on to the feeling of the sky as a blanket, a vast, protective, multi-layered blanket. Feel the sense of being sheltered, held. The air you breathe is its closest fold. The blue sky is its daytime color. The starry vault is its nighttime pattern. The warmth you feel comes filtered gently through its layers. The shooting stars are tiny reminders of its shielding power. It surrounds us completely, this invisible embrace. It stretches from the blades of grass at your feet, touching the ground, right up to the edge of space itself, hundreds and hundreds of miles above. It's a deep, deep blanket, thicker and more complex than we can easily imagine. But its purpose is simple: to keep our Earth, our home, safe and sound, to create a gentle haven in the vastness of the universe. So, as you rest, imagine yourself snuggled deep within this sky blanket. Feel its immense, quiet presence arching over you. Appreciate the filtered sunlight, the breathable air, the stable warmth. Know that even when you sleep, the blanket is there, doing its silent work, layer upon layer, shielding, filtering, warming, protecting. It's the Earth's own cozy covering, and we are all resting peacefully beneath it, snuggled under the sky blanket. Allow that feeling of safety and peace to wash over you, like the softest, gentlest wave, knowing you are held securely within its invisible, layered folds. And the very first fold of this magnificent blanket, the one resting right against the skin of the Earth, the layer where we find ourselves nestled, is called the troposphere. It's the layer closest to home, the one we know most intimately, even if we don't always think of it by name. It begins right here, where you are resting. It touches the cool floor beneath you, the soft bed you lie upon, the blades of grass just outside your window, the very dust motes dancing in a stray moonbeam. It rises up from the ground, embracing everything we see and touch in our daily lives. Imagine it as the softest, deepest pile of the sky blanket, the part woven with the threads of our own world. It holds the familiar scent of rain-washed earth, the perfume of night-blooming flowers, the distant murmur of the sleeping world. It's thick with the very substance of life, the air we draw into our lungs with every quiet breath. Feel that breath now, the gentle rise and fall of your chest. That air, cool and refreshing as it enters, slightly warmer as it leaves, is the essence of the troposphere made tangible. It's mostly invisible nitrogen, a quiet, stable presence, but woven through it is the vital oxygen that sustains us, that fuels the gentle rhythm of our sleeping bodies. It's a gift, this breathable air held close to the Earth by the gentle pull of gravity, concentrated here in this bottommost layer. This troposphere isn't static. It's alive with movement, like a slow, deep river flowing around the globe. We feel this movement as the breeze. Sometimes it's just a whisper, barely stirring the curtains, a faint coolness against your cheek if a window is open just a crack. Other times, it's a more definite sigh through the trees, rustling the leaves in a gentle lullaby. These currents, these invisible streams of air, mix everything together within the troposphere. They carry warmth from sunny lands over cooler oceans. They lift moisture from lakes and seas. They distribute the seeds of plants and the spores of fungi, weaving the web of life across the continents. This constant, gentle churning is what makes the troposphere the home of our weather. Think of the weather not as something disruptive, but as the troposphere simply expressing itself, breathing and shifting. Picture a soft, drizzly rain tapping lightly against the window pane. Each tiny droplet began its journey high above within this layer, perhaps clinging to a microscopic speck of dust, growing heavier and heavier until gravity gently coaxed it back to Earth. That rain is the troposphere returning borrowed water, cleansing the air, nourishing the soil, singing a soft, percussive song on rooftops and leaves. Or imagine a quiet winter evening with snowflakes drifting down like tiny, intricate feathers. Each one is a frozen jewel, formed in the colder reaches of the troposphere, tumbling slowly through the air, blanketing the world in silence and softness. The snow, too, is part of this layer's gentle cycle, a different form of water returning to the ground, resting there until the warmth coaxes it back into liquid or vapor. Even the warmth you might feel, the gentle heat radiating from the ground long after the sun has set, is held within the troposphere. Sunlight passes through the upper layers, warming the surface of the earth, the land, and the oceans. The troposphere, like the bottommost layer of a cozy duvet, traps much of this warmth near the surface, preventing it from radiating away too quickly into the coldness of space. It keeps the nights from becoming impossibly frigid, maintaining a balance that allows life to flourish. As you climb higher within the troposphere, up towards the peaks of the tallest mountains, the air generally grows colder, thinner. It's as if the blanket is thickest and warmest right down here where we live, becoming gradually less dense as you move away from the Earth's surface. And then there are the clouds. The troposphere is the grand gallery of clouds, the canvas upon which these masterpieces of water vapor are painted daily. Look up in your mind's eye, into the daytime sky held within this layer. See the big, puffy cumulus clouds like heaps of freshly gathered cotton wool, or perhaps those fluffy sheep drifting lazily across a vast blue meadow? They seem so solid, yet they are merely collections of tiny water droplets or ice crystals suspended in the air, constantly changing shape as the air currents sculpt them. They drift and merge, grow tall and majestic, or dissipate into nothingness, reflecting the restless energy of the troposphere. Sometimes, the sky is streaked with high, wispy cirrus clouds, looking like delicate brushstrokes of white paint or strands of fine silk pulled across the blue. They reside near the very top of the troposphere, where the air is thin and freezing cold, composed entirely of ice crystals. They catch the light of the setting or rising sun in spectacular ways, glowing pink and gold and orange long after the sun has dipped below the horizon, a final, beautiful sigh from the edge of our layer. At other times, a low, gray sheet of stratus cloud might cover the sky like a soft, neutral ceiling. It doesn't have the drama of the cumulus or the delicacy of the cirrus, but it brings a feeling of quiet enclosure, diffusing the sunlight into a gentle, even glow, perhaps promising a soft rain later on. These stratus clouds are like another layer of the blanket, tucked just above us, creating a sense of closeness, of the sky being near. All these clouds, in all their infinite variety, exist only within the troposphere. They are born here. They live their ephemeral lives here, drifting on its currents, and they dissolve back into invisible vapor here, or return their water to the earth as rain, snow, or hail. They are perhaps the most visible manifestation of the troposphere's character, its moisture, its movement, its temperature changes. Watching them is like watching the breath of the planet made visible. This layer, our home, isn't uniform in height. It's thicker over the warm equator, bulging outwards like a well-stuffed cushion, reaching perhaps 12 miles high. Over the colder poles, it's thinner, compressed, perhaps only 4 or 5 miles deep, but even at its thickest, it's still a remarkably thin skin compared to the size of our planet. Imagine the Earth as an apple. The troposphere would be thinner than the apple's skin. Yet, within this delicate layer, almost all life as we know it exists. The birds that sing their morning chorus, the insects that buzz in the summer air, the tallest trees reaching towards the sun, the deepest roots anchoring into the soil. All are participants in the life of the troposphere. Even the airplanes we sometimes see tracing white lines across the blue are flying near the very top of this layer, cruising in the smoother air just below the boundary that separates the troposphere from the layer above. They are temporary visitors to its upper edge, while we remain nestled in its depths. It's here, in the troposphere, that the air pressure is greatest. We don't usually feel it, because we're accustomed to it, like fish are accustomed to the pressure of water. But the weight of all the air in the layers above presses down, concentrating the air molecules here, making the air dense enough for us to breathe easily, dense enough to carry sound waves effectively, the distant train whistle, the chirp of a cricket, the gentle rhythm of your own breathing. It's a pressure that holds us comfortably contained within our world. So, as you lie here, feeling the gentle weight of your own blanket, think of the troposphere as the Earth's own familiar covering. It's the layer of gentle breezes and soft rains, of drifting clouds and breathable air. It's the layer that holds the scent of pine needles after a shower, the warmth of a sunbeam on your skin, the coolness of morning mist rising from a field. It's the busy, dynamic, life-filled bottom fold of the great sky blanket. It's not empty space above us. It's a place, a region, an environment. It's our neighborhood in the sky. Feel its presence around you, this layer we live in, extending from the ground beneath you up to where the highest clouds drift. It's a place of constant, gentle change, yet also a place of stability, holding the conditions for life just right. Let the thought of this cozy, familiar layer, our troposphere, deepen your sense of peace, knowing you are resting safely within its embrace, breathing its air, sheltered by its substance, right here at the bottom of the sky. Even now, as you rest, nestled and still, the air around you is rarely perfectly motionless. It might seem quiet, utterly calm in the darkness of your room, but beyond the walls, within this vast troposphere that holds us, the air is almost always breathing. It shifts and stirs, sighs and flows in currents too gentle, often for us to notice immediately. Think of the lightest touch, the barest whisper against your skin. That's how the air sometimes moves. It's the beginning of wind, not the howling gales of storms, but the softest breezes, the atmosphere's quiet exhalations. This gentle movement begins with the sun's warmth, unevenly spread across the Earth's surface. Imagine the ground, the fields, the forests, the oceans, all basking in daylight. Some parts warm up quicker than others. Dark soil drinks in the heat, while water reflects much of it away. Where the ground grows warmer, it gently heats the air directly above it. Warm air, you see, is lighter, more buoyant, like a bubble rising silently through water. So, this warmed air begins to lift, slowly, imperceptibly ascending into the sky within our troposphere. It rises like a quiet thought, an unspoken wish lifting towards the ceiling of our atmospheric room. As this warmer, lighter air floats upward, something must take its place. Nature, in its quiet wisdom, dislikes empty spaces. So, cooler, heavier air from nearby areas begins to slide in gently to fill the space left behind. It doesn't rush. It flows, like cool water settling into a hollow. It moves along the surface, a soft current nudging its way across the land. This movement, this gentle sliding and shifting of air from cooler places to warmer places, is what we feel as a breeze. It might be the subtle stirring of leaves on a tree outside your window, their surfaces catching the moving air like tiny sails. It might be the faint rustle of curtains, breathing in and out with the unseen currents. Perhaps you've felt it on a warm day, a sudden, welcome coolness brushing against your cheek, a momentary relief. That's the cooler air arriving, sinking softly, displacing the warmth. These are the gentle winds of the troposphere, the constant, quiet balancing act of warm air rising and cool air descending. They are invisible rivers flowing around us, shaping the weather, carrying scents and sounds, all within this layer closest to home. These breezes are the atmosphere's way of distributing warmth, ensuring no single place gets too hot or too cold, a gentle stirring that keeps the air fresh and alive. It's a dance of temperatures, a silent choreography performed by the air itself, orchestrated by the sun's uneven touch and the Earth's varied surface, all happening within the familiar confines of our tropospheric neighborhood. Feel the air in the room, still and calm perhaps, but know that just outside, these gentle currents are likely flowing, whispering through the night. And what do these rising currents of warm air carry with them, besides their warmth? They carry something invisible, something essential for life and for the beauty of the sky: water vapor. Tiny, tiny particles of water, far too small to see, lifted from oceans, lakes, rivers, damp soil, even the leaves of plants. This moisture mixes with the air, becoming part of it, held in suspension as it begins its slow ascent. Think of steam rising from a warm drink, how it disappears into the air. Water vapor does the same, merging invisibly with the lifting warmth. As this warm, moist air rises higher into the troposphere, it encounters cooler temperatures. Just as the ground is warmest and it gets colder as you climb a mountain, the air generally gets colder the higher you go within this layer. When the rising, invisible water vapor meets this cooler air, something magical begins to happen. The cold encourages the tiny water vapor particles to stop drifting independently and start gathering together. They condense, changing from an invisible gas back into minuscule liquid water droplets or, if it's cold enough, tiny ice crystals. Suddenly, what was invisible becomes visible. These countless microscopic droplets or crystals suspended in the air, gather together, catching the light. They form clouds. Imagine dust motes dancing in a sunbeam, invisible until the light catches them just right. Cloud droplets are like that, billions upon billions of them, appearing out of the seemingly clear air as they rise and cool. They are not solid objects, not really. They are more like floating gatherings of mist, vast collections of tiny water bits held aloft by the very air currents that helped form them. These are the soft clouds we see drifting lazily across the daytime sky or catching the moonlight in ethereal shapes at night. They are born within the troposphere, children of rising warm air and cooling temperatures. Think of the puffy, cotton wool shapes of cumulus clouds on a fair day. They often have flat bases, marking the level where the rising air cooled enough for condensation to begin, and rounded, billowing tops showing where the warm air continues to bubble upwards. They look soft, gentle, like peaceful sheep grazing in the blue pasture of the sky. Or perhaps you picture the high, wispy cirrus clouds, stretched thin like brushstrokes of white paint or strands of fine silk. These clouds form much higher in the troposphere, where it's very cold, so they are made mostly of tiny ice crystals. They drift on the high-altitude breezes, often hinting at changes in the weather to come, but appearing serene, detached, almost transparent against the deep blue. They are delicate whispers made visible, ice crystal formations catching the sunlight miles above us, yet still comfortably within our home layer. These clouds are not static paintings. They are dynamic, ever-changing. They drift and merge, grow and dissipate, sculpted by the winds at different altitudes within the troposphere. Watching them can be like watching a slow, silent ballet. They are carried by those same air currents, those gentle breezes and stronger winds that flow at various heights. A cloud might seem still from down here, but it is constantly moving, constantly evolving, its shape shifting as droplets evaporate back into vapor on one edge while new droplets condense on another. They are visible manifestations of the air's invisible dance, floating islands in the atmospheric ocean, telling stories of moisture and temperature and movement high above our heads. They are part of the troposphere's gentle breathing, made visible and beautiful. And what happens within these soft, drifting clouds? Those tiny water droplets or ice crystals, born from the cooling of rising air, don't just hang there forever. They are jostled by air currents within the cloud, bumping into each other. When droplets collide, they can merge, forming larger, heavier droplets. It's a slow process, a gentle gathering. Imagine tiny specks gradually joining together, becoming slightly bigger specks, then bigger still. As these droplets grow, they become heavier. The rising air currents that helped form the cloud and keep the smaller droplets afloat might struggle to support these larger, combined drops. Eventually, a droplet can become so heavy that the air currents can no longer hold it up. Gravity, that gentle but persistent pull towards the earth, takes over. The droplet begins to fall. When millions upon millions of these droplets become heavy enough to fall, we experience rain. Or, if the cloud is high enough and cold enough, ice crystals might grow large and heavy, falling as snowflakes. But let's think about the gentle rain first. the kind that falls from softer, less dramatic clouds. It's not the torrential downpour of a thunderstorm, but a quieter, more soothing precipitation. It might start as a fine drizzle, a mist settling over the landscape, dampening the leaves and the ground with a soft touch. Or it might be a light shower, the drops distinct but falling gently, creating a soft pattering sound on roofs and windowsills. This is the rain that sounds like quiet lullabies. Listen closely in your mind to the sound of gentle rain. It's often rhythmic, a steady, soft drumming, pitter-patter, pitter-patter. It's a sound that can be incredibly calming, washing away the day's distractions, creating a sense of enclosure and peace, especially when you are tucked up warmly inside. This gentle rain, falling from the clouds nurtured within the troposphere, is a gift to the earth. It waters the plants, allowing them to grow, replenishing rivers and lakes. It washes the dust from the air, leaving it feeling cleaner and fresher. Think of the smell after a soft rain shower has passed. That clean, earthy scent known as petrichor. It's the smell of the thirsty ground drinking in the moisture, the scent of life being renewed. The rain connects the sky back to the ground, completing a cycle. Water evaporates, rises as vapor, condenses into clouds, and then returns as rain, all within this protective layer, our troposphere. So, the gentle breezes, the soft clouds, the quiet rain, they are all part of the troposphere's weather whispers. They are the results of simple, elegant processes. The uneven heating of the earth, the rising and cooling of air, the condensation of water vapor, the gentle pull of gravity. They are not separate events, but deeply interconnected. The breezes carry the moisture. The rising air builds the clouds release the rain. It's a continuous flowing cycle, a quiet engine running constantly within our atmospheric home. These phenomena are the heartbeat of the troposphere, the signs of its life and dynamism. They happen right here, in the layer we inhabit, shaping our days and nurturing the world around us. They are usually gentle, subtle, working quietly in the background. The breeze you barely notice, the cloud drifting overhead, the soft shower that passes quickly. These are the everyday expressions of the atmosphere's presence. Think of them not as disruptions, but as part of the natural rhythm, like breathing. The air moves, clouds form and dissolve, rain falls and nourishes. It's all part of the balance, the constant, gentle adjustment happening within the Earth's familiar blanket. As you lie here, feeling safe and sheltered, picture these quiet processes unfolding above and around you. The air stirring softly outside, perhaps carrying the scent of damp earth or distant blossoms. Clouds drifting silently overhead, perhaps veiled by darkness but still present, holding their moisture. The memory or anticipation of gentle rain, washing the world clean, singing its soft lullaby. These are the weather whispers of the troposphere, reminding us of the gentle, life-sustaining cycles held within this precious layer, our neighborhood at the bottom of the sky. Let the thought of these quiet movements and transformations deepen your sense of peace, a reminder of the constant, gentle care enveloping our world. Now, let your awareness continue its gentle ascent, rising softly from the familiar embrace of the lower air. Imagine yourself floating upwards, effortlessly, leaving behind the realm where clouds are born and breezes stir the leaves. You drift higher and higher, above the tallest mountain peaks shrouded in mist, above the highest drifting clouds that mark the ceiling of the everyday weather world. The air, which felt so present and active below, begins to feel different, thinner, yet imbued with a new kind of presence, one of stillness. You are approaching an invisible threshold, a boundary known as the tropopause. It isn't a wall, but a gentle transition, like wading from moving shallows into the deeper, calmer water beyond. Here, the air stops getting colder as you rise, pausing as if taking a quiet breath before beginning a slow, subtle warming trend. This pause marks the gateway to the next great layer of our atmosphere. As you drift across this unseen boundary, You enter the stratosphere. The change is palpable, not in a sudden jolt, but in a profound settling of the air around you. The constant vertical churning, the rising and falling currents that create the weather you left below, simply cease. It is as if you have passed through a veil into a realm of immense quietude. The weather whispers of the troposphere fade into an echo, then silence. Here, the air lies in smooth, undisturbed sheets, stretching vast distances across the curve of the Earth. Imagine immense, invisible layers of gossamer silk, stacked one upon the other, lying flat and still. This is the essence of the stratosphere. Strata meaning layers. The air doesn't mix vertically here. It rests, stratified, stable. This profound stability comes from that gentle warming trend you noticed starting at the tropopause. Warmer air naturally wants to stay above cooler air. So here, unlike below, there's no inherent drive for the air to tumble and turn. It creates an environment of extraordinary calm, a deep peace pervading this high-altitude domain. Feel the immense serenity of this place. It stretches from about 10 kilometers above the surface, higher than any mountain, reaching up to perhaps 50 kilometers, far beyond the reach of ordinary clouds and storms. Below you, the troposphere might be swirling with activity, thunderstorms building, winds gusting, rain falling. But here, an abiding tranquility reigns. It is a zone of horizontal movement, where winds can flow smoothly for thousands of miles without the bumps and jostles common nearer the ground. Think of it as a vast, calm ocean layer, lying deep beneath a surface stirred by waves and wind. Down there is the constant motion of weather. Up here is the deep, slow, quiet current. The air is incredibly thin compared to what you breathe at sea level, yet it forms a substantial protective layer for the planet. Within this serene, layered expanse resides something truly vital, though invisible to the eye: the ozone layer. Picture it not as a thick blanket, but as a sparse, delicate distribution of special oxygen molecules. Ozone, woven throughout the middle and upper parts of the stratosphere. Though thinly spread, this layer performs a crucial task with quiet efficiency. Imagine it as a subtle, protective filter, a planetary parasol. As sunlight streams down from space, carrying intense ultraviolet energy, this ozone layer acts like a sieve. It intercepts much of the harshest UV radiation, absorbing its energy. This absorption is gentle, silent, happening molecule by molecule across vast areas, but it has two profound effects. Firstly, it shields life on the surface, far below from the most damaging rays of the sun, a silent guardian working constantly above our heads. Secondly, this absorption of energy is what gently warms the stratosphere, creating the temperature inversion, the warming with height, that gives this layer its characteristic stability and calm. So, the very peace of the stratosphere is intimately linked to this silent, protective work being done by the ozone within it. Feel the subtle warmth generated by this process. Not a heat you could feel on your skin, but an energetic signature that defines the character of this atmospheric layer, making it a place of stillness rather than turmoil. While the stratosphere is defined by its lack of conventional weather, it is not entirely without its own subtle phenomena, visible only under rare and specific conditions. Sometimes, in the deep cold of polar winters, incredibly high, thin clouds can form near the very top of the stratosphere. These are not the puffy cotton clouds of the troposphere. They are ethereal, shimmering veils known as nacreous clouds, or mother-of-pearl clouds. Imagine wisps of iridescent color, pinks, greens, blues, painted across the twilight sky, long after the sun has set on the world below. They are made of tiny ice crystals or droplets forming in temperatures far below freezing, catching the lingering sunlight from their great height. They are rare, fleeting, and incredibly beautiful, a reminder that even in this calm, stable layer, subtle and delicate processes can unfold. They don't bring storms or rain. They are simply high-altitude artistry, silent brushstrokes of light in the upper atmosphere, visible only to those looking closely at the right moment, hinting at the extreme cold and unique conditions found so high above the Earth. And flowing within this vast, stable layer, particularly near its lower boundary with the tropopause, are powerful currents of air known as the jet streams. Don't picture them as chaotic winds, but rather as immense, high-speed rivers of air, flowing smoothly and swiftly around the planet. They meander like earthly rivers, but are thousands of kilometers long and hundreds wide, moving at speeds that can exceed 200 miles per hour. These are not turbulent storms, but focused currents within the generally calm stratospheric flow. High-altitude jet aircraft often seek out these powerful currents. Imagine a sleek aeroplane climbing high above the bumpy weather of the troposphere, reaching the lower stratosphere, and slipping into one of these atmospheric rivers. The ride becomes incredibly smooth, the plane carried along effortlessly, saving time and fuel on its long journey across continents or oceans. Picture yourself aboard such a flight, cruising peacefully in the lower stratosphere. Look out of the window. Below, you might see the flat top of a vast cloud deck belonging to the troposphere, stretching like a field of snow towards the horizon. Above, the sky is a deeper, darker blue than you see from the ground, hinting at the thinning air and the proximity of space. There's a profound sense of quiet speed, of gliding smoothly through this calm upper realm, detached from the world below. The jet stream is a hidden pathway, a current of energy used by those who travel at these heights, a testament to the dynamic processes that can exist even within this predominantly peaceful layer. From this vantage point, high in the calm stratosphere, the perspective shifts. Looking down, the curvature of the Earth becomes more apparent. Continents and oceans spread out below, their features softened by distance. The weather systems you left behind in the troposphere appear as slow-moving swirls and patterns of white cloud, their energy contained far beneath you. It's like watching a silent movie of the world's weather, beautiful and intricate, but distant. There's a sense of detachment, of being above the fray. Looking upwards, the sky transitions towards the blackness of space. During the day, the blue is deeper, purer. As twilight approaches, the stars emerge with greater clarity and brilliance than seen from the ground, less obscured by the dense, hazy air of the lower atmosphere. You are closer to the edge of space, in a region that bridges the dense, active atmosphere below and the near vacuum above. This journey into the stratosphere is a journey into profound calm. It is a layer defined by its stability, its layered structure, its lack of turbulent weather. It is warmed gently by the silent work of the ozone layer, which also protects the world below. It hosts rare, beautiful clouds of ice and light, and smooth, powerful rivers of air used by high-flying jets. It offers a unique perspective, looking down on the familiar world and up towards the cosmos. Let the image of the stratosphere settle in your mind, a vast, serene sanctuary high above the busy Earth, a place of immense quiet, of smooth flows and protective layers. Feel the peace of this high-altitude haven, a reminder of the varied and wondrous structure of the atmosphere that surrounds and protects our world. As you rest, imagine the stillness of this layer, the silent absorption of sunlight, the smooth glide of air currents far overhead, a realm of profound atmospheric peace. Within this profound stillness, this vast expanse of quiet air high above the churning weather of the world, something truly remarkable is happening. It unfolds silently, continuously, almost like a secret whispered between the sunbeams arriving from the void and the sparse molecules of this high, serene realm. It involves a special kind of air, a unique arrangement of oxygen atoms known as ozone. Perhaps you've heard of ozone in a different context, down near the ground, where it can sometimes be part of the hazy air in bustling cities, an unwelcome guest in the air we breathe directly. But here, elevated far above the surface, suspended in the calm clarity of the stratosphere, ozone transforms its role entirely. It becomes a guardian, an essential protector, a silent benefactor to all life nestled far below. Imagine this ozone not as a pollutant, but as a different kind of oxygen breath. The air we usually breathe is made of two oxygen atoms holding hands, a stable pair vital for our lungs. Ozone is a little different. It's like a small family of three oxygen atoms linked together. A trio, slightly less stable, perhaps, but capable of performing an extraordinary task in this specific place. This subtle difference in structure, just one extra atom, allows ozone to interact with sunlight in a very special way. Now, this protective ozone doesn't form a single solid barrier, like a sheet of glass stretched across the sky. You couldn't reach out and touch its edge. Instead, picture it as a delicate, utterly invisible mist, diffused and spread out, woven through the lower and middle portions of the stratosphere. It's most concentrated many miles above the highest clouds you left behind in the troposphere, yet even at its densest, it's still incredibly sparse compared to the air near sea level. It's a layer in the sense of being a distinct region where this molecule is more abundant, hiding in plain sight within the deepening blue of the stratospheric sky. It's less a shield and more like a vital dye, subtly tinting the atmospheric window through which sunlight must pass. Think for a moment about the sunlight itself, embarking on its long journey from the fiery heart of the sun, traveling across the immense, silent emptiness of space to reach our small blue planet. This sunlight is a river of energy, carrying many things life needs. It carries the gentle warmth that thaws frozen landscapes, coaxes seeds to sprout, and makes the surface of the earth feel welcoming. It carries the visible light that paints the dawn sky with color, allows plants to create their food, and lets our eyes perceive the beauty of the world. It is, in so many ways, the source of energy that drives the rhythms of life. But carried within this same stream of sunlight, invisible to our eyes, are also rays that possess a much fiercer energy. These are the ultraviolet rays, often called UV light. Think of them as carrying too much energy for delicate life, like a musical note played far too loudly, or a touch that is too rough, too intense. While some gentle UV light can be beneficial, the stronger types carry enough raw power to potentially harm the delicate cells and structures of living things if they were to reach the surface in their full, unfiltered strength. They carry the sun's untamed power. This is where the ozone layer, this sparse, invisible mist of three-atom oxygen molecules, performs its gentle, silent miracle. As the sunlight streams down from above, entering the stratosphere, it encounters this region where ozone resides. And these special ozone molecules, these little trios, act like the most perfectly formulated, incredibly gentle sunscreen imaginable, spread carefully and continuously across the entire sky by the atmosphere itself. When one of the sun's overly energetic, invisible ultraviolet rays arrives, traveling at the speed of light, an ozone molecule, you might imagine, softly steps into its path. It doesn't engage in a violent collision or a forceful battle. Instead, in a moment of quiet chemistry, the ozone molecule calmly absorbs the harsh energy of that specific ray. It takes that excessive intensity into itself, embracing it. In that fleeting instant of absorption, the ozone molecule itself is often changed. The energy it takes in is frequently just the right amount to break one of the bonds holding the three oxygen atoms together. The trio might gently separate, becoming an ordinary two-atom oxygen molecule, the kind we breathe, and a single, free oxygen atom. But this isn't a destructive end. It's simply part of a continuous, quiet cycle. It's a transformation, not an annihilation. This act of absorbing the strong UV ray and breaking apart does two crucial things. Firstly, it stops that specific harmful ray from continuing its journey down towards the Earth's surface. It has been intercepted, its excessive energy safely handled. Secondly, the energy doesn't just vanish, it's converted. Some of it is used in the breaking of the ozone bond. Often, the resulting pieces, the oxygen molecule and the lone oxygen atom, might later recombine, perhaps with other atoms, to form ozone once more, ready to absorb another ray. Or, the absorbed energy might simply be released as gentle heat, warming the surrounding very thin air of the stratosphere. This quiet absorption, this process of intercepting harsh UV light and transforming its energy into gentle warmth, happens countless billions of times every second, all across the sunlit side of the Earth. Within this diffuse ozone layer, it is this constant, silent work that is primarily responsible for the stratosphere's unusual temperature profile, the way it gets warmer as you go higher, unlike the troposphere below. The ozone layer is effectively capturing energy that would otherwise be harmful below and using it to gently heat its own atmospheric layer, contributing to the profound calm and stability we imagined earlier. It's a silent, tireless filtration system, powered by the very sunlight it moderates. Imagine the sunlight continuing its journey downwards after passing through the ozone layer. The harsh, potentially damaging ultraviolet rays have been largely filtered out, absorbed, and converted into the gentle warmth of the stratosphere. What passes through is a softer, more nurturing form of sunlight. The visible light still shines brightly, painting the world in color. The gentle infrared warmth still reaches the surface, keeping the planet temperate. But the fiercest, most energetic part of the sun's ultraviolet spectrum has been significantly reduced, toned down to levels that life on the surface has adapted to over millions of years. The ozone layer doesn't act like a complete blackout curtain, blocking all sunlight. That would leave the world cold and dark. Instead, it functions more like a sophisticated filter, selectively removing the too much, the overly intense wavelengths, while allowing the beneficial light and warmth to pass through. It's like a careful, cosmic guardian, ensuring that the sun's energy arrives as a blessing, perfectly moderated for the delicate balance of life below. And why is this gentle filtering so profoundly important? Because life on Earth, in all its wondrous diversity and intricate delicacy, has evolved under this filtered sunlight. Our skin, the leaves of the tallest trees, the petals of the smallest flowers, the tiny plankton drifting in the sunlit upper layers of the ocean, all are adapted to the sun's moderated gaze, thanks to the unseen work of the ozone layer far above. Without this invisible shield, the sun's unfiltered ultraviolet energy would pour down with an intensity that could damage DNA, hinder plant growth, and make the surface environment far less hospitable, less comfortable for the myriad forms of life that call Earth home. It could make the world feel harsh, unwelcoming, potentially sterile. The ozone layer, therefore, acts like a vast, comforting atmospheric blanket, allowing the Earth below to bask safely and productively in the sun's life-giving glow. It helps maintain a world gentle enough for bare feet to walk on sun-warmed grass, for tender new leaves to unfurl without being scorched, for eyes to look up towards the vastness of the blue sky without immediate harm. It preserves the cradle of life. This protective layer isn't a static, unchanging feature. It possesses a subtle dynamism, a gentle rhythm of its own. Ozone is constantly being created within the stratosphere, primarily when high-energy sunlight interacts with ordinary two-atom oxygen molecules, splitting them apart so single atoms can then combine with other O2 molecules to form ethereal, ozone. At the same time, ozone is constantly being naturally broken down, either by absorbing that strong UV sunlight as we've discussed, or through interactions with other trace gases in the atmosphere. It exists in a state of delicate natural balance, a continuous cycle of creation and destruction, making and unmaking, like a slow planetary breath. This balance ensures that the layer persists, maintaining its protective embrace around our world, though its thickness can subtly fluctuates across seasons and latitudes. A subtle ebb and flow in its protective power. Leaving behind this vital shield, this region where sunlight performs its intricate chemistry with oxygen, we continue our journey upward, floating higher still. The air, already thin in the upper reaches of the stratosphere, grows even more tenuous. The feeling is one of rising into an ever quieter space, leaving the denser, more active layers far below. We ascend past the stratopause, the boundary marking the peak of the stratosphere's warmth, and drift into a new realm, a layer known as the mesosphere. Meso meaning middle. This is the atmosphere's middle child, poised between the relative warmth below and the intense heat that lies much further above. As we enter the mesosphere, which typically begins around 50 kilometers, or 31 miles, above the Earth's surface, a profound change occurs. The warmth generated by the ozone layer's absorption of ultraviolet light fades rapidly. There is little here to capture the sun's energy directly. The air density drops dramatically. The molecules of nitrogen and oxygen, along with other trace gases, become incredibly scarce, spread far, far apart. Imagine the air you breathe, the gentle pressure on your skin, and then imagine that air stretched out, thinned to almost nothingness. Here, the molecules are so few and far between that they rarely collide. Because temperature is essentially a measure of the energy of moving molecules and how often they interact, this scarcity means the mesosphere becomes extraordinarily cold. The higher we climb through this layer, the colder it gets. It's a reversal of the trend we saw in the stratosphere. Here, warmth is a memory of the layers below. The mesosphere plunges into temperatures colder than any natural place on the surface of the Earth. Think of the most frigid Antarctic night, the deepest freeze of a polar winter. The upper mesosphere is colder still. Temperatures plummet towards minus 90 degrees Celsius, minus 130 degrees Fahrenheit, and sometimes even lower. It is a realm of deep, penetrating cold, a silent, frozen stillness suspended high above the bustling world. The air is a near vacuum, a whisper of gas in the vastness, holding barely any heat, existing in a state of profound chill. It seems almost empty, this high, cold place. Too thin to support clouds as we know them near the ground, too thin to easily scatter sunlight and create the familiar blue sky. Looking up from within the mesosphere, the sky would appear much darker, closer to the blackness of space, with the sun a fiercely bright disk against it. It's a transitional zone, less like the air we know and more like the prelude to the void beyond. One might wonder what could possibly happen in such a sparse, frigid expanse. Yet, it is precisely this emptiness, this cold stillness, that sets the stage for moments of fleeting, breathtaking beauty. For the mesosphere, despite its thinness, is the first significant atmospheric layer that tiny visitors from outer space encounter at high speed. Our solar system is not truly empty. It's filled with dust and debris, small particles shed by comets as they loop near the sun, fragments chipped off asteroids in cosmic collisions, remnants from the formation of the planets billions of years ago. Most of these particles are incredibly small, tiny specks of rock and metal, often no larger than a grain of sand or a small pebble. They drift through the vacuum of space, silent and unseen, traveling at immense velocities, tens of thousands of miles per hour. For most of their journey, space is so empty that these particles travel unimpeded, but as they approach Earth, drawn by its gravity, they eventually reach the upper tendrils of our atmosphere. While the layers above the mesosphere, the thermosphere and exosphere, are even thinner. The mesosphere is where the air density, though still incredibly low by surface standards, becomes just substantial enough to make a difference. Imagine one of these tiny cosmic pebbles, perhaps the size of a pea, hurtling towards Earth. It enters the upper mesosphere, moving at maybe 40 kilometers per second. That's over 89, 0 miles per hour. At first, nothing happens. The air molecules are too few and far between. But as it plunges deeper into the mesosphere, encountering slightly denser, though still extremely thin, air, it starts colliding with air molecules. At such tremendous speeds, these collisions are incredibly energetic. It's not like a gentle breeze pushing against the particle. It's more like the particle slamming into the sparse molecules with unimaginable force. This creates intense friction. The air molecules directly in the path of the incoming particle, called a meteoroid while it's in space, are compressed and heated almost instantaneously to thousands of degrees Celsius. This intense heat causes the surface of the tiny rock or speck of dust itself to vaporize, turning directly from solid to gas. The surrounding air molecules are also heated so much that they glow, ionized and excited by the energy transfer. What we see from the ground, looking up into the night sky, is not the tiny particle itself. It's far too small to be visible from dozens of miles below. What we see is the luminous trail of superheated, glowing gas it leaves in its wake as it burns up. This bright streak of light, flashing across the darkness for a fleeting moment, is what we call a meteor, or more poetically, a shooting star. It's a beautiful paradox. In one of the coldest layers of our atmosphere, these tiny visitors from the cold depths of space create brief, incandescent trails of fire. They are like sleepy sparks, waking for just an instant as they encounter our world's embrace. Most meteoroids are completely vaporized high in the mesosphere, long before they could ever reach the ground. Billions of them enter our atmosphere every single day, mostly unseen, adding tons of cosmic dust to our planet. But the larger ones, those pebble-sized or slightly bigger, create the visible shooting stars that have captivated stargazers for millennia. Think of it, a tiny grain of sand, journeying for perhaps millions of years through the silent darkness between planets, ends its cosmic voyage in a brief, brilliant flash tens of miles above your head. It happens in the blink of an eye, a streak of light, a silent wish whispered into the night, and then it's gone, leaving only the memory and the dark stillness. The mesosphere is the stage for this nightly celestial fireworks display, a protective layer that incinerates the vast majority of this incoming cosmic debris, turning potential impacts into harmless, beautiful streaks of light. These shooting stars are like dreams flickering through the high atmosphere, brief visions of light born from the encounter between the vastness of space and the gentle edge of our world's air. The mesosphere doesn't just host these fiery trails. Its extreme cold and the dust left behind by vaporized meteors create another, much more subtle and ethereal phenomenon: noctilucent clouds. These are the highest clouds in Earth's atmosphere, forming right near the top of the mesosphere, around 76 to 85 kilometers, 47 to 53 miles high. They are also known as polar mesospheric clouds, or night-shining clouds. Unlike the familiar tropospheric clouds made of water droplets or larger ice crystals, noctilucent clouds are thought to be composed of minuscule ice crystals, perhaps only nanometers wide, that form on the tiny dust particles left behind by meteors. They need incredibly cold temperatures to form, temperatures found only in the summer mesosphere near the poles. Why summer? It seems counterintuitive, but complex atmospheric wave dynamics actually cause the polar mesosphere to be coldest during its hemisphere's summer, reaching those frigid lows below minus 120 degrees Celsius, minus 184 degrees Fahrenheit. In these conditions, the scarce water vapor present at that altitude can freeze onto the meteor dust. Because they are so high and the air is so thin, these clouds are incredibly faint. We can only see them from the ground during deep twilight, when the sun has set below the horizon for observers on the surface, but its rays can still reach and illuminate these lofty clouds against the darkening sky. They appear as delicate, shimmering veils of electric blue or silvery white, often with intricate ripples and tendrils sculpted by high-altitude winds. They look otherworldly, like faint, ghostly curtains hanging silently at the edge of space. Seeing them is a rare treat, a glimpse into the mysterious, frigid upper reaches of the mesosphere, a reminder of the unseen dust from shooting stars coalescing into ice in the deep cold. They are like frozen whispers of the meteor's passage, lingering long after the fiery streaks have faded. So, the mesosphere, this middle sphere, is a place of stark contrasts. It is profoundly cold, colder than anywhere on Earth's surface, with air stretched to an almost imperceptible thinness. Yet, it is also a place of sudden, fleeting fire, where tiny messengers from space end their journeys in brief, brilliant flashes of light, the shooting stars that inspire wonder and wishes. And in its highest, coldest reaches, under specific conditions, it can host the delicate, ghostly beauty of noctilucent clouds, woven from cosmic dust and ice. It is a quiet layer, a buffer zone high above the weather and the ozone shield, silently performing its duty of intercepting cosmic debris. transforming potential impacts into sleepy sparks that dance across the night sky, reminding us of the vast, dynamic universe beyond our atmospheric cradle and the delicate layers that protect us within it. As we drift higher still, leaving the realm of shooting star dreams behind, the air will become even thinner, the connection to the Earth below more tenuous as we approach the gateway to space itself. Leaving behind the realm of frozen whispers and meteor trails, we continue our ascent, drifting ever higher. The mesopause, that coldest boundary we just crossed, marks a turning point. Below it lay the deepening chill of the mesosphere, but as we float gently upwards into the next vast layer of our atmospheric ocean, something strange begins to happen. The temperature, which had plummeted steadily through the stratosphere and mesosphere, begins to climb again. And not just climb, but soar. We are entering the thermosphere, the heat sphere, a region that stretches hundreds of kilometers above us, merging gradually with the vacuum of space. The air here is thinner still, unimaginably so. If the mesosphere felt like an almost imperceptible thinness, the thermosphere is rarefied to an extreme that defies easy comparison. The molecules of gas, still mostly nitrogen and oxygen, just like near the ground, are now incredibly far apart. Imagine wandering through a colossal, empty cathedral, so vast that you might only encounter another person every few hours. Here, the gas molecules are like those solitary wanderers in an immense void. Down near the surface, air molecules are constantly jostling, colliding billions of times every second, sharing their energy. Here, a molecule might travel a kilometer or more before encountering another. The density is minuscule, less than a billionth of the air density at sea level. It is, for all practical purposes, a vacuum, far more empty than any vacuum we can easily create in a laboratory on Earth. Yet, paradoxically, this near-empty space is incredibly hot. The thermo in thermosphere isn't misleading. Temperatures here climb dramatically, reaching levels far higher than any experienced on Earth's surface. Depending on the sun's activity, the upper reaches of the thermosphere can register temperatures of 500, 1000, even 2000 degrees Celsius or more. Hotter than a blast furnace, hotter than molten lava. How can this be? How can a near vacuum be so intensely hot? The answer lies in the way temperature is defined and the energy arriving from the sun. Temperature is a measure of the average kinetic energy of particles, how fast they are moving or vibrating. Here in the thermosphere, the few gas molecules that exist are directly exposed to the sun's most powerful, high-energy radiation, extreme ultraviolet rays, and X-rays. This fierce energy, filtered out long before it reaches the ground, is absorbed directly by these sparse molecules. When a molecule of oxygen or nitrogen absorbs this high-energy radiation, it's like giving it a powerful push. It starts moving incredibly fast, vibrating violently, zipping through the void with tremendous kinetic energy. Because the average speed of these energized molecules is so high, the temperature is correspondingly high. Each individual particle is indeed extremely hot. But feeling heat requires more than just fast-moving particles. It requires the transfer of that energy. Think of it like standing in a vast, dark, empty warehouse on a cold night. If someone occasionally shot a single, tiny, red-hot spark past you from the far end, you wouldn't feel warm. Even though each spark is intensely hot, they are too few and far between to transfer any significant heat to you. Your own body would continue to lose heat to the surrounding cold emptiness much faster than it gained heat from the occasional passing spark. The thermosphere is like that warehouse. The individual gas molecules are the tiny, super-energized sparks, moving at incredible speeds, possessing high temperatures. But there are so few of them, spread so far apart in the immense emptiness, that they rarely collide with each other, let alone with any object passing through. If you could somehow float here, protected from the vacuum and radiation but exposed to the air, you wouldn't feel hot. You would feel the penetrating cold of space, the rapid loss of your own body heat into the void. A standard thermometer, designed to measure heat transfer through collisions, would register a temperature far below freezing because it would radiate its own heat away much faster than it could absorb energy from the sparse, high-speed molecules bumping into it occasionally. It's a profound difference between temperature as a measure of individual particle energy and heat as the transfer of that energy. The thermosphere possesses incredibly high temperatures, but very little actual heat content. It's like a warm breath puffed into a gigantic, freezing hall. The breath itself might be warm, but it does almost nothing to warm the hall itself or you standing within it. The energy is there, carried by individual particles dancing furiously in the emptiness, but the medium is too thin, too wispy, to effectively share that warmth. This intense solar radiation doesn't just heat the molecules, it also tears them apart. High-energy ultraviolet photons have enough power to break the bonds holding diatomic molecules like oxygen, O2, and nitrogen, N2, together. This process, called photodissociation, means that as we go higher into the thermosphere, we find more and more individual atoms of oxygen, O, and nitrogen, N, existing alongside their molecular forms. Atomic oxygen, in particular, becomes a significant component of this lofty realm. The thermosphere is vast, beginning around 80 or 90 kilometers up, just above the mesopause, and extending outwards for hundreds of kilometers. Its upper boundary, the thermopause, is ill-defined and highly variable, typically considered to be somewhere between 500 and 1,000 kilometers, sometimes even higher. This is the region where Earth's atmosphere gradually fades into the exosphere, and then into the true vacuum of interplanetary space. It's a huge volume, containing only a tiny fraction of the atmosphere's total mass. Within this immense, hot but empty layer, humanity has established its first permanent outposts beyond the denser atmosphere. Many satellites, including the Hubble Space Telescope in its lower reaches, and crucially, the International Space Station, ISS, orbit within the thermosphere. Astronauts aboard the ISS are not swimming through hot gas. They are protected within their heavily shielded habitat, essentially flying through a vacuum that happens to contain very sparse, very energetic particles. From their vantage point, they witness the breathtaking curve of the Earth below, draped in swirling clouds, continents, and oceans, all outlined by the incredibly thin, bright blue ribbon of the denser atmosphere hugging the limb of the planet. Above them is the stark, infinite blackness of space, studded with stars far clearer than any seen from the ground. And it is here, within this tenuous, energized layer, that one of Earth's most spectacular natural phenomena occurs: the aurora. The shimmering, dancing lights of the aurora borealis, northern lights, and aurora australis, southern lights, are born in the thermosphere. They are the result of a cosmic connection between the sun and our planet's atmosphere, mediated by Earth's magnetic field. The sun constantly streams out a flow of charged particles, electrons and protons, known as the solar wind. As this solar wind sweeps past Earth, our planet's magnetic field acts like a protective shield, deflecting most of it. However, the magnetic field lines converge near the north and south magnetic poles, creating funnels. Some charged particles from the solar wind become trapped within the magnetic field and are guided along these field lines down towards the polar regions. As these energetic electrons and protons plunge into the upper atmosphere, they collide with the sparse atoms and molecules residing in the thermosphere, primarily oxygen and nitrogen. These collisions are like tiny, high-energy impacts. They transfer energy to the atmospheric atoms and molecules, exciting them, kicking their electrons into higher energy states. But atoms don't like to stay excited for long. Almost immediately, they release this excess energy by emitting photons, tiny packets of light. We see the combined effect of billions upon billions of these collisions as the aurora. The colors depend on which type of atom or molecule was struck, and at what altitude. Collisions with oxygen atoms typically produce the most common color, a luminous, ethereal green, usually occurring around 100 to 240 kilometers altitude. At higher altitudes, above 240 kilometers, where oxygen is even sparser, Collisions can produce beautiful all-red auroras, which are often seen during intense solar storms. Collisions with nitrogen molecules tend to produce blues, purples, and pinks, often visible at the lower edges of auroral curtains or during particularly energetic events. Imagine watching this celestial ballet unfold. Silent curtains of light ripple and wave across the night sky. Great arcs stretch from horizon to horizon, pulsating gently. Rays of light shoot upwards like search beams from an unseen source. Ribbons of green and pink twist and fold in on themselves, constantly shifting, seemingly alive. It is a profoundly beautiful and humbling spectacle, a direct visualization of the invisible forces connecting our planet to the sun, painted onto the vast, dark canvas of the upper atmosphere. And it all happens here, in the thermosphere, where the sun's energy meets the thin vanguard of Earth's air, sparking it into light. The thermosphere is not a static place. Its temperature, density, and height fluctuate dramatically, driven primarily by the ever-changing activity of the sun. During periods of high solar activity, marked by numerous sunspots and frequent solar flares, the sun emits more intense X-ray and EUV radiation. This extra energy input causes the thermosphere to heat up even more and to expand outwards, puffing up like a loaf of bread rising. This expansion increases the atmospheric drag on satellites orbiting within it, including the ISS. Even though the air is incredibly thin, there's still enough friction at orbital speeds, around 28 kilometers per hour, to gradually slow satellites down, causing their orbits to decay if they don't receive periodic boosts. Mission controllers must constantly monitor solar activity and its effect on the thermosphere to manage satellite orbits effectively. Conversely, during periods of solar minimum, the thermosphere cools and contracts, becoming less dense. So, let us rest here for a moment, conceptually floating in this strange realm. It is a place of profound emptiness, where the silence is absolute, broken only by the whisper of solar radiation and the occasional collision of particles too sparse to make a sound we could hear. The pressure is virtually zero. The feeling is not one of conventional heat, but of exposure to the vast, cold void, punctuated by the invisible, high-speed dance of individual, energized molecules. It's a place where the sun's most potent energies are absorbed, creating temperatures hotter than fire in a medium thinner than breath. It hosts our mechanical emissaries exploring the edge of space and provides the stage for the silent, luminous spectacle of the aurora. The thermosphere is the atmosphere's fiery outer shield, absorbing the sun's harsh glare, glowing softly at the poles, a transition zone where Earth's embrace loosens, molecule by lonely molecule, reaching out towards the infinite. It is warm, yes, but in a way that speaks more of energy than substance, a final, wispy sigh before the true beginning of space. And within this sigh, within this vast, energetic emptiness of the thermosphere, another kind of warmth reveals itself, not as temperature that you could feel on your skin, but as light. A soft, ethereal glow that paints the polar skies with colors borrowed from dreams. This is the realm of the aurora, the silent, luminous spectacle hinted at before, a gentle ballet performed on the very edge of space. Here, in the thin, electrically charged air high above the sleeping world, the sky itself can seem to come alive, breathing color and motion into the long polar nights. Imagine looking up from a quiet, snow-covered landscape, far away from the glare of city lights. The air is crisp and cold, biting at your cheeks, and your breath puffs out in white clouds that vanish into the darkness. The stars are brilliant, scattered like diamond dust across black velvet. But then, something else begins. Faintly at first, perhaps a pale greenish arc, low on the horizon, so subtle you might wonder if your eyes are playing tricks. It looks like a distant luminous cloud, but it holds a different quality, a soft radiance that seems to come from within. Slowly, almost shyly, this light gathers strength. It is not harsh or sudden, but unfolds with a quiet grace. The arc might begin to brighten, to climb higher into the sky. And as it does, it may begin to shift and change. This is where the dance truly begins. Think of immense ribbons of light unspooling across the heavens. Ribbons woven from colors so delicate, so pure, they seem otherworldly. The most common color is a gentle luminous green, the color of phosphorescence on a dark sea, or perhaps the soft glow of moonlight filtering through young leaves in spring. It's a peaceful, calming green washing swathes of the night sky. But other colors join the dance. Sometimes, the lower edges of these green ribbons might be fringed with pink or a soft rose color, like the blush on a cloud at sunset, lingering long after the sun has departed. Higher up, much higher, where the air is even thinner, you might glimpse shades of red, from a deep ruby to a soft, diffuse crimson glow, like wine spilled on dark silk. And occasionally, rarer blues and violets might appear, deep and mysterious, hinting at the complex energies at play far, far above. These colors are not painted on like pigment. They are light itself, generated molecule by molecule in the rarefied air of the thermosphere. The source of this celestial light show lies far away, with the sun. Our star is constantly breathing out a stream of charged particles, tiny pieces of itself, known as the solar wind. This invisible wind travels across the vastness of space, carrying energy from the sun. As it approaches Earth, it encounters our planet's magnetic field, an invisible shield that surrounds us. Most of the solar wind is deflected, flowing around the Earth like water around a smooth stone. But near the North and South poles, the magnetic field lines dip down towards the planet's surface, creating funnels. Through these magnetic funnels, some of the energetic particles from the sun can stream downwards, guided by the invisible lines of force. They plunge into the upper reaches of our atmosphere, deep into the thermosphere, the very layer we have been exploring. And here, traveling at incredible speeds, they collide with the sparse atoms and molecules of gas that still linger, primarily oxygen and nitrogen. Imagine these tiny collisions happening billions upon billions of times, scattered across huge regions of the sky. Each collision transfers energy to the atmospheric atom or molecule, exciting it, like gently nudging someone who is resting. This extra energy cannot be held for long. The atom or molecule wants to return to its calm, resting state. To do so, it releases the excess energy, and it does this by emitting a tiny particle of light, a photon. It is these countless photons, born from countless collisions between solar particles and Earth's atmospheric gases high in the thermosphere, that create the light we see as the aurora. The specific colors depend on which type of atom or molecule is struck, oxygen or nitrogen, and how high up the collision occurs. Oxygen atoms, when excited at higher altitudes in the very thin air, tend to glow red. Lower down, where the air is slightly denser, excited oxygen often emits that characteristic beautiful green light. Nitrogen molecules, when energized, can contribute the blues, violets, and the pink or crimson fringes, sometimes seen along the lower edges of the auroral curtains. So, the thermosphere, this layer of incredible heat generated by absorbed solar radiation, also becomes the canvas for this light show. The same energy processes that make it hot also provide the conditions for the aurora to shine. The thinness of the air allows the lights to form distinct shapes and structures, rather than just a uniform glow. And the shapes, they are mesmerizing in their variety and fluidity. Sometimes the aurora appears as vast, silent curtains hanging folds of light from the zenith down towards the horizon. These curtains can seem incredibly thin, yet stretch for hundreds, even thousands of kilometers. They are rarely static. They ripple slowly, as if unseen breezes were blowing through the upper atmosphere. The folds shift and sway, the colors brightening and fading along their lengths. Watching them, you might feel as if you are witnessing the very fabric of the night breathing. At other times, the aurora forms distinct rays, like searchlight beams pointing upwards from the horizon, reaching towards the stars. These rays can stand alone or appear in bundles, sometimes fanning out across a large portion of the sky. They might shimmer or pulse with light, brightening and dimming rhythmically, adding another layer to the silent performance. Or the aurora might appear as a diffuse patch of light, a soft, hazy glow without distinct form, perhaps covering the entire sky overhead in a gentle wash of pale green or milky white. Sometimes, the display is quiet, a gentle arc, or a soft, slow-moving band. On other nights, when the solar wind is stronger and carries more energy, the aurora can become incredibly active and dynamic. The curtains might seem to race across the sky, twisting and swirling in intricate patterns. Rays might shoot upwards rapidly, and the colors can intensify dramatically. The entire sky can feel alive with movement, a truly breathtaking spectacle. Yet, even at its most active, the aurora unfolds in profound silence. There is no sound accompanying the lights, no rushing wind, no crackle or hum that reaches the ground. The dance happens in a realm too thin for sound waves to carry effectively to our ears. This deep silence, contrasted with the immense visual drama unfolding above, adds to the feeling of magic and wonder. This beautiful phenomenon has two names, depending on where on Earth you might see it. In the northern hemisphere, near the Arctic Circle, it is called the aurora borealis, or the northern lights. In the southern hemisphere, near Antarctica, it is the aurora australis, the southern lights. They are mirror images of each other, born from the same process, as solar particles stream into both polar regions simultaneously. They are shimmering ribbons tied around the top and bottom of our world. Imagine standing there, wrapped in warmth against the cold, head tilted back, gazing up at this celestial performance. The sheer scale is difficult to comprehend. These lights are happening hundreds of kilometers above your head, in the thermosphere. The curtains of light might be taller than mountains, wider than entire countries, yet they appear delicate, ethereal. There is a sense of peace that descends when watching the aurora. The slow, graceful movements, the soft colors, the profound silence, it all encourages a quiet contemplation. You feel very small, yet connected to something vast and beautiful, a witness to the subtle interactions between our planet and its star, made visible in the most enchanting way. It's a reminder that even in layers of the atmosphere that seem empty and remote, incredible beauty can unfold. The thermosphere, absorbing the sun's harshest ultraviolet and X-ray radiation, protecting life below, also uses that energy, channeled by Earth's magnetic field, to create these gentle, fleeting masterpieces of light. It is a place of extremes, extreme temperatures, extreme emptiness, and yet it hosts this soft, slow dance. These sky ribbons are not permanent fixtures. They appear when the conditions are right, when the sun sends energetic particles our way and Earth's magnetic field guides them into the polar thermosphere. They shift, they change, they fade, sometimes disappearing entirely, leaving only the stars behind. They are transient, ephemeral, like a beautiful dream you try to hold on to as you wake. So, as we think about the layers of our atmosphere, let's remember the thermosphere not just as a hot, thin shield, but as the grand theater for the aurora. Picture those soft curtains of green, pink, and red light swaying gently in the near vacuum far above. Imagine the silence, the vastness, the cool air around you, and the soft, colorful glow reflecting on the snow or the dark water. It's a quiet reminder of the intricate connections that link our planet to the sun and to the cosmos beyond, painted in strokes of light across the polar night sky. A final, luminous whisper from the atmosphere before it dissolves into the true void of space. A gentle lullaby of light, dancing softly, high above the sleeping Earth. And as those ethereal lights fade, as the last soft brushstrokes of the aurora melt back into the high, dark canvas, the thermosphere settles into a profound quiet. The silence up here is immense, a stillness that stretches beyond comprehension, broken only by the whisper of physics, the subtle dance of particles in near nothingness. The stars, no longer dimmed by the auroral glow, reclaim their full brilliance, scattered like diamond dust across an infinite expanse of velvet black. They don't twinkle here. They shine with a steady, piercing light, unfiltered by the denser air, far, far below. It is in this realm, this incredibly thin upper reach of Earth's atmospheric embrace, hundreds of kilometers above the sleeping surface, that another kind of light moves. It doesn't flicker or dance like the aurora. It doesn't pulse or flare. It is a steady point of light, tracing a deliberate, silent arc across the starfield. Too fast for a star, too constant for a meteor, it glides with an unhurried grace. This is the International Space Station, humanity's outpost on the edge of the void, making its home in the tenuous upper reaches of the thermosphere. It doesn't belong to the wild natural light show of the aurora, born of solar winds and magnetic fields. It is something different, something built, something placed here. Yet it moves with a serenity that seems perfectly attuned to the vast silence surrounding it. Imagine it now, floating in that near vacuum. It isn't a simple point of light when seen closer, but a complex structure, a delicate assembly of modules, trusses, and arrays. Its most prominent features are its vast solar panels, great rectangular wings that seem too large, too fragile for any world with strong winds or heavy gravity. Up here, though, they hang weightlessly, perpetually angled towards the sun, drinking in its energy. In the unfiltered sunlight, they might gleam with a harsh intensity, but as the station slips into Earth's shadow or catches the light at dawn or dusk from this high vantage, they often glow with a softer, warmer hue, deep golds, coppers, and bronzes, reflecting the light of a sun that has already set or not yet risen for the world below. The station itself is a collection of cylindrical modules, connected like beads on a string, interspersed with the intricate latticework of its truss structure. Small lights, markers, and indicators dot its surface, but they are pinpricks against the sheer scale of the vessel and the darkness around it. It moves without a sound, propelled not by roaring engines, but by the inescapable laws of orbital mechanics, a constant state of falling around the Earth. It drifts, glides, floats, words that try to capture a motion that is both incredibly fast, covering kilometers every second, yet feels utterly serene and effortless from afar and even from within. It's a gentle, ceaseless waltz with gravity, performed on the grandest of stages. Picture yourself looking out from one of its windows, perhaps the large, multi-windowed cupola that faces the Earth. The view is breathtaking, sublime. Below, the planet curves away in a majestic arc. You can see the thin, luminous band of the atmosphere clinging to the edge, a fragile, iridescent blue halo separating the familiar world from the infinite blackness. It's this very atmosphere, specifically the thermosphere, that the station flies through. It's so incredibly thin here, thinner than the best vacuums created in labs on Earth, yet it's still present. Enough molecules exist, scattered far and wide, that they exert a tiny, almost imperceptible drag on the station, causing its orbit to slowly decay over time, requiring occasional boosts to stay aloft. It's a constant, gentle reminder that even here, hundreds of kilometers up, Earth still holds on, its atmospheric breath reaching out into the near-space environment. Looking down, the Earth unfolds like a living map. During the day, continents are vast patches of ochre, brown, and green, swirling with cloud patterns like delicate white lace or thick, fluffy wool. Oceans are a profound, deep blue, reflecting the sunlight in dazzling patches. You can sometimes make out coastlines, the sharp edges where land meets water, or the faint outlines of mountain ranges. There are no borders visible, no signs of the divisions drawn on maps, just the natural, flowing beauty of the planet's surface. Then, as the station sweeps across the terminator, the line dividing day and night, the view transforms. The edge of darkness rushes towards you, or you rush towards it. Sunlight catches the tops of the highest clouds, painting them pink and orange, while the surface below sinks into shadow. On the night side, the Earth becomes a dark sphere, sprinkled with glittering constellations of city lights. Clusters of light-outlined coasts trace rivers, or bloom in intricate networks across the land. Some are sharp white, others a softer yellow or orange. They seem fragile, like scattered embers against the immense darkness of the continents and oceans. Above these sleeping cities, thunderstorms sometimes flicker, brief, silent flashes of light within the clouds, visible only from this high vantage point. And through it all, the station moves silently, steadily. It completes an orbit around the Earth roughly every 90 minutes. This means that those aboard experience a sunrise or a sunset every 45 minutes. Imagine that rhythm, the brilliant, unfiltered glare of the sun flooding the cabin, then the swift transition into the deep shadow of the Earth, where the stars blaze and the city lights twinkle below, followed again by the breathtaking spectacle of orbital dawn. The colors shifting rapidly along the atmospheric limb. It's a cycle of light and dark, compressed into a fleeting hour and a half, repeated over and over. Inside this orbiting outpost, shielded from the vacuum and the extreme temperatures of the thermosphere, which can swing wildly from scorching heat in direct sunlight to deep cold in shadow, humans live and work. We don't need to picture their busy schedules or complex experiments right now. Instead, just imagine the quiet moments. Someone pausing by a window, looking down at the familiar, beloved curve of their home planet. Perhaps they see a swirl of clouds over their hometown, or the lights of a city where loved ones sleep. There's a profound sense of connection, and perhaps a touch of melancholy in being so far away, yet having such a clear, encompassing view of the whole world. They are caretakers of this unique place, temporary residents of the thermosphere, living representatives of the world scrolling silently beneath them. From this vantage point, the thermosphere isn't just a layer defined by temperature or altitude. It's a place, a location, a neighborhood. It's the zone where the fading wisps of Earth's atmosphere mingle with the first hints of true space. It's thin enough for orbits to be relatively stable, yet thick enough to host the fiery trails of meteors burning up far below the station's path, and to glow with the soft light of the aurora during solar storms. The station exists within this layer, constantly interacting with it in subtle ways, breathing in the barest traces of air, feeling its faint drag. Looking away from Earth, the view is equally profound, but in a different way. If the Earth below is familiar, comforting, vibrant with color and light, the view outwards is one of stark, stunning emptiness, punctuated by the fierce, unwavering light of countless stars. The Milky Way stretches across the blackness, not as a faint band often obscured by light pollution on the ground, but as a brilliant, textured river of light, thick with stars and nebulae. Other galaxies are visible, faint smudges of light, entire universes held in a single glance. There is no up or down, just the vast sphere of Earth on one side, and the infinite, star-dusted void on the other. The station floats precisely at this boundary, a tiny, intricate vessel navigating the transition zone. It continues its journey, a silent sentinel in the high heavens. It passes over sleeping continents, over vast, dark oceans reflecting the moonlight, over swirling storms and clear night skies. Its path is predictable, mapped, tracked by watchers on the ground who sometimes look up and see its steady light gliding overhead, a human-made star among the ancient constellations. It carries dreams, aspirations, and the quiet hum of life support systems through the silent thermosphere. Think of it now, as you settle deeper into quietness. Picture this structure, gleaming softly with reflected sunlight or the faint glow of its own internal lights, drifting peacefully high above. It's a place of science, of exploration, but tonight, let's just see it as a quiet watcher. It circles the Earth, a constant presence in the thermosphere, while below, the planet breathes. Forests sleep, cities dream under their blankets of light, oceans heave in slow rhythms. The station glides on, bathed in the light of distant stars and the faint ethereal glow of the atmospheric limb. It is a part of our world, yet apart from it, a testament to curiosity nestled in the final, tenuous layers of our atmosphere, keeping a silent, steady vigil over the sleeping Earth. A man-made moon, tracing its calm, endless path through the quiet theater of the upper air, a gentle companion to the night. Let us continue our gentle ascent, rising slowly, weightlessly, leaving even the high path of that orbiting outpost far below. We float upwards from the thermosphere, that realm of surprising heat and northern lights, moving beyond the altitudes where satellites trace their steady arcs. The air, already thinner than anything we know on the ground, begins a final, almost imperceptible vanishing act. It's less like climbing higher and more like dissolving into an ever-expanding quiet. Imagine the atmosphere not as layers stacked neatly like blankets, but as a single entity, densest at the bottom, gradually, patiently thinning with height, until here, at the very summit, it simply frays away into nothingness. We are entering the exosphere. The name itself comes from the Greek word exo, meaning outside or external. This is the outermost region, the true edge of our atmosphere, the place where Earth's breath mingles with the vacuum of space. There is no clear line, no sudden boundary to cross. It is a transition zone, vast and undefined, beginning perhaps 500 or 600 kilometers up, maybe 700, and stretching outwards for thousands more, 10,000 kilometers, perhaps even further, its upper limits blending imperceptibly with the interplanetary medium. It's like wading out from a shoreline into an infinite ocean. The ground slopes away gently beneath your feet. The water deepens gradually, until you are no longer touching the bottom, simply floating, suspended between the world you left behind and the endless expanse before you. Here, the concept of air as we understand it ceases to hold meaning. The particles are so incredibly far apart that they rarely interact. Imagine grains of luminous sand scattered across a desert stretching for thousands of miles under a black sky. Down in the troposphere where we live, trillions upon trillions of molecules jostle in every cubic centimeter, colliding billions of times per second, creating pressure, carrying sound, supporting weather. Even in the thermosphere, collisions, though less frequent, still define the behavior of the gas. But here, in the exosphere, a particle can travel for hundreds, even thousands of kilometers on a solo journey before encountering another. These lonely travelers are mostly the lightest gases, hydrogen and helium. Having floated upwards through all the denser layers below, like corks rising through water, they populate this outermost fringe. Occasionally, a heavier atom, perhaps oxygen or nitrogen, might be energetic enough to make a temporary excursion this high, but predominantly, it is the realm of the lightweights. They are the final, ethereal wisps of our planet's gaseous envelope. Think of them now, these individual atoms and molecules, drifting in the profound silence. They are energized by the unfiltered sunlight, moving at high speeds. If you could measure the kinetic energy of a single particle here, you would find it corresponds to a very high temperature, thousands of degrees Celsius, even hotter than the thermosphere below. But this is a temperature that exists only in the speed of these isolated particles. There are so few of them, scattered so widely, that they carry virtually no heat energy. An object placed here wouldn't be warmed by these fast-moving but sparse atoms. Instead, it would rapidly radiate its own heat away into the surrounding emptiness, becoming intensely cold. It's the profound, deep space cold, touched only by the distant, fierce light of the sun and the even more distant light of the stars. The particles here don't behave like a gas anymore, swirling and mixing under pressure. Instead, they move like tiny projectiles launched from below. Each atom or molecule follows its own path, a long, curved trajectory dictated primarily by Earth's gravity. Imagine countless microscopic fountains spraying silently upwards into the blackness. Many of these particles arc high into the exosphere, slow down as gravity gently pulls them back, and then fall, tracing a graceful parabola back towards the denser atmosphere below. They are on long, elliptical orbits or ballistic paths, temporary visitors to the edge before returning home. But some particles, those with enough speed and moving in the right direction, achieve something remarkable. They reach escape velocity. They possess just enough energy to overcome Earth's gravitational embrace. Their upward arc doesn't curve back down. Instead, it continues outwards, ever slower, perhaps, but never reversing. These particles gently, irrevocably drift away. They are not shot out forcefully. It's a slow, quiet departure, atom by single atom. This is the Earth's atmosphere, slowly, constantly, leaking into space. A gentle exhalation, losing its lightest components over vast stretches of time. Hydrogen, created perhaps from water vapor, dissociated by sunlight lower down, rises to the top and eventually, some of it drifts away forever. Helium, released from radioactive decay within the Earth's crust, also makes its way up here, and some of it too joins the outward stream. It is a silent, steady process, the planet breathing out into the cosmos. Imagine floating here, suspended in this immense quiet. What would you see? Below, the Earth hangs like a magnificent jewel, a vast, curved presence dominating the view downwards. Its familiar patterns of blue oceans, swirling white clouds, and tan continents are starkly defined against the black. The limb, the edge of the planet's atmosphere, might still show a faint, thin glow, but it's much less substantial than the fuzzy halo seen from lower orbits. It's a sharper edge now, the final threshold. Above and all around, the blackness of space is absolute. It's a velvet void, deeper and more profound than any night sky seen from the ground. And against this perfect black, the stars. They don't twinkle here. Twinkling is caused by the light passing through the shifting densities of the lower atmosphere. Here, the stars are sharp, steady points of intense light. They seem brighter, colder, perhaps more numerous, filling the void with their ancient fire. The Milky Way, our galaxy's seen edge on, would stretch across the sky like a luminous river, its structure more clearly defined. The sun, when in view, is an object of blinding intensity, its light unfiltered by any significant atmosphere, casting razor-sharp shadows. The moon, other planets. They are not soft neighbors in a blue sky, but stark, perfectly defined spheres hanging in the infinite dark. And the sound? There is none. Absolute, complete silence. Sound needs a medium, molecules close enough together to bump into each other and pass vibrations along. Here, the void is too vast, the particles too few and far between. The silence is so profound, it might feel like the loudest thing here. It's not just the absence of noise, but the presence of utter stillness, a quiet that penetrates, that emphasizes the immense scale of everything around you. The quiet of the void between worlds. What would it feel like to be here? Gravity is still present, of course, holding the Earth below, guiding the paths of the escaping atoms, keeping the moon in orbit. But the sensation would be one of perfect weightlessness, of effortless floating. There is no atmospheric pressure, no wind, no sense of being surrounded or supported by air. Just the feeling of being suspended in an infinite space. Perhaps a sense of profound solitude, but a peaceful solitude, like being the only consciousness in a vast, silent cathedral of stars. A feeling of being infinitesimally small, yet part of this immense cosmic tapestry. It is the feeling of being truly on the edge, balanced between the warmth and life of the world below and the cold, silent eternity of space. This is the true frontier. The exosphere is where Earth's domain gently yields to the domain of the sun and the wider solar system. It's where the solar wind, the constant stream of charged particles flowing outwards from the sun, becomes the dominant environmental factor, an invisible river carrying the sun's breath across the interplanetary void. Here, beyond the last whispers of terrestrial air, beyond the final tenuous grip of Earth's atmosphere, lies the beginning of true space. It isn't a hard line, Not a wall you pass through, but rather a slow, imperceptible fading, like wading out into a perfectly still ocean at twilight, where the warmth of the shore gradually surrenders to the cool, deep embrace of the water. The Earth's influence simply dissolves around you. The sparse atoms of the exosphere, already far-flung and lonely, become indistinguishable from the particles that have journeyed millions of miles from our star, or perhaps from even further away, across gulfs of time and distance we can barely comprehend. You have drifted beyond the blue, beyond the thin shell that cradles our world, into the quiet, unending blackness. This is the realm often called empty, the vacuum of space, and in human terms, it is almost incomprehensibly empty. Where moments ago, even in the exosphere, there were still a few million atoms scattered through a cubic centimeter. Here, there might only be a handful, perhaps just one or two, adrift in that same volume. Imagine the air you breathe, dense with molecules jostling and colliding trillions upon trillions of times each second, carrying scents and sounds, pressing gently against your skin. Now imagine that air thinned out, stretched beyond imagination, until the space between one particle and the next is a vast desert, wider than continents. There is no pressure here, no substance to push against, no medium to carry the familiar vibrations of sound. The silence is not merely an absence of noise, it is the nature of the place itself. A silence so profound, so complete, it feels like the universe holding its breath, listening to something far beyond our perception. It sinks into you, this quiet, replacing the constant hum of the world with a stillness that seems to stretch forever. Yet, empty is not quite the right word, not entirely true. This immense void is permeated by things unseen, unfelt in the way we feel a breeze or the warmth of a fire. It is flooded with light, the ancient, unwavering light of distant stars, the fierce, unfiltered glare of the nearby sun. Photons, tiny messengers of energy born in nuclear furnaces trillions of miles away or just next door in our own star, crisscross the void constantly, carrying images of galaxies born billions of years ago, painting pictures on any receptive surface, like your eyes. The solar wind continues its relentless journey outwards, a ghostly stream of protons and electrons, flowing past planets and moons like phantom water around stones, eventually mingling with the interstellar medium far beyond the furthest orbit, a tenuous breath connecting the sun to the galaxy. Cosmic rays, high-energy particles accelerated by supernova explosions or the churning hearts of active galaxies, zip through this space at nearly the speed of light, silent bullets from the deep cosmos, whispering tales of unimaginable violence happening across impossible distances, and tiny grains of dust, micrometeoroids shed by comets during their fiery passages near the sun, or chipped from asteroids in slow collisions long ago, drift like motes in a sunbeam glimpsed in a quiet room, occasionally flashing into brief existence as they strike a surface, tiny sparks in the overwhelming dark. It is not empty, but rather filled with radiation, with subtle energies, and with the potential for encounter, however rare. It is an emptiness defined by the vast distances separating these minuscule components, an emptiness that holds everything apart in a state of suspended isolation. Look around you in this boundless expanse. If you were to turn back, you would see the Earth, no longer a world filling your view, but a beautiful, marbled sphere hanging in the blackness. A precious jewel of blue oceans, swirling white clouds, and continents of brown and green, radiating a faint warmth, a beacon of impossible life in the surrounding desolation. Its atmospheric skin, which seemed so vast and deep from below, now appears as a paper-thin, luminous halo, glowing with a delicate blue light, the fragile boundary you have just crossed. It is a sight of breathtaking beauty, and perhaps a little melancholy, a reminder of the warmth, the sounds, the life, the connection left behind. It hangs there, serene and complete, a testament to the conditions that allow for breath and birdsong. But turn away from Earth, let it drift behind you, and look outwards into the deep. The perspective shifts entirely. The darkness is absolute, a velvet black deeper than any night sky seen from the ground, untroubled by scattered light or atmospheric haze. And against this perfect canvas, the stars blaze, not twinkling as they do from below, but shining with a fierce, unwavering intensity. Countless points of light, distant suns scattered across infinity, cold and remote. There is no up or down, only the vast, silent emptiness stretching away forever. It is a silence that presses in, profound and absolute, the silence of the void. It is beautiful, yes, in its stark grandeur, but it is the beauty of utter indifference, a coldness that chills not the body, but the soul. But let your thoughts drift gently back towards that beautiful blue marble hanging in the void. Let the immensity of space fade for a moment, and remember the feeling of home. Picture that delicate, luminous halo again, that paper-thin skin of atmosphere you saw from afar. It seems so fragile from out here, doesn't it? A mere whisper of gas against the crushing emptiness. Yet, within that fragile boundary lies everything that means warmth, safety, and life. It is not just a boundary, it is an embrace. Think of it now, as you settle into stillness, as Earth's gentle hug. This hug isn't tight or constricting. It's a soft, encompassing presence, a series of nested layers wrapping around our world, each playing its part in creating the haven we call home. It holds us, cradles us, protects us from the harshness you glimpsed out there in the deep black. It's the reason we can close our eyes and drift into dreams, utterly safe and sound. Feel the outermost edge of this embrace, the exosphere. It's not really a layer like the others, more like the finest, most delicate fringe of Earth's atmospheric shawl. Here, the air is so incredibly thin, molecules drift far apart, some escaping Earth's gentle pull to wander into space, like dandelion seeds caught on an upward breeze. But even here, at this threshold between worlds, Earth's influence lingers. It's the first point of contact with the solar wind, that constant stream of particles flowing from the sun. The exosphere, wispy and ethereal, helps to slow and deflect some of this invisible cosmic weather. The very first, almost imperceptible touch of the protective hug, whispering a gentle "not here" to the harshest elements of space. It's the quiet transition, the place where Earth's breath fades into the silence of the cosmos. Beneath this fringe lies the thermosphere. Imagine this layer as a vast, incredibly lightweight blanket held high above the world. The air is still exceptionally thin, thinner than anything we experience on the ground, yet the few molecules that exist here perform a vital task. They eagerly absorb the sun's most energetic rays, the extreme ultraviolet and X-ray radiation. By catching this intense energy, the molecules here become incredibly energized, making this layer surprisingly hot, though you wouldn't feel it as heat because the particles are too far apart to transfer much warmth. Think of it as absorbing the sun's fiercest glare, transforming it before it can reach us below. This is also the magical realm where the auroras dance, the northern and southern lights. Charged particles from the sun, guided by Earth's magnetic field, collide with the sparse atoms here, causing them to glow in breathtaking curtains of green, pink, and violet light. They are like sleepy, silent fireworks painting the polar skies, a beautiful reminder of the invisible shield working tirelessly far above, turning potential harm into ethereal beauty, a lullaby sung in light at the edge of space. This layer is a silent guardian, absorbing harsh energy, transforming it into gentle light shows for those who dwell below. Drifting deeper into Earth's embrace, we reach the mesosphere. Picture this as a slightly thicker, yet still incredibly high, part of the atmospheric blanket. It's a cooler layer, nestled between the warmth above and the layers below. Its special gift is protection from celestial visitors. Countless tiny fragments of rock and dust, remnants from the formation of our solar system, hurtle through space. We call them meteoroids. Most are no bigger than grains of sand or tiny pebbles. As they plummet towards Earth at incredible speeds, they hit the mesosphere. The air here, while still thin, is dense enough to create friction, intense friction. The meteoroids burn up brightly, streaking across the night sky as fleeting trails of light, shooting stars. We see them from below, make a wish perhaps, and seldom realize we're witnessing our atmospheric shield in action. The mesosphere acts like a cosmic incinerator, vaporizing almost all of these intruders long before they could ever reach the ground. It's a quiet, constant defense, turning potential impacts into harmless, beautiful light shows. It's another layer of the gentle hug, intercepting cosmic debris, ensuring our peace below remains undisturbed by falling stones from the sky. Feel the safety in knowing this layer is always there, diligently catching those falling stars, keeping the path clear for quiet nights and peaceful dreams. Beneath the mesosphere lies a truly special layer, the stratosphere. Imagine this part of the embrace as having a particularly fine, almost invisible weave within it. This is the home of the ozone layer. Ozone is a special kind of oxygen molecule, and though it exists in relatively small amounts, it forms a crucial shield within the stratosphere. Think of it as planetary sunglasses. It absorbs the majority of the sun's harmful ultraviolet B, UVB, radiation. This is the energy that can cause sunburn and damage living tissues. The ozone layer acts like a natural filter, allowing the sun's life-giving light and warmth to pass through, but blocking the harshest, most damaging rays. It ensures that the sunlight reaching the surface is gentle enough for life to flourish, for plants to grow, for our skin to feel warmth without immediate harm. The stratosphere itself is a calm layer, with steady horizontal winds rather than the turbulent weather below. High-altitude planes sometimes cruise here, above the clouds. It's a place of relative stillness, diligently performing its filtering task. This layer is a vital part of Earth's gentle hug, quietly ensuring the sunlight that kisses our world is nurturing, not harmful. It allows us to enjoy the daylight, to feel the sun's warmth on our faces, knowing we are protected by this invisible, essential shield woven into the atmospheric blanket high above. Finally, we sink into the layer closest to us, the one we live and breathe in every moment, the troposphere. This is the very heart of Earth's gentle hug, the densest and most dynamic layer, extending from the ground up to where the clouds paint the sky. Feel its presence around you now. This is the air that fills your lungs with each quiet breath. It carries the scent of rain-washed earth, of blooming flowers, of pine needles warmed by the sun. It's the layer where all our weather happens. The gentle breezes that rustle leaves outside your window, the soft pitter-patter of rain on the roof, the fluffy white clouds drifting lazily across a blue sky, the morning mist that blankets valleys in silence. These aren't just weather phenomena. They are the expressions of the troposphere, the most tangible part of Earth's embrace. The clouds, like soft cotton wool or wispy brushstrokes, are part of this layer's comforting presence. They carry moisture, bringing the rain that nourishes the land and fills the rivers. They provide shade on a warm day, diffusing the sunlight into a softer glow. The air pressure here is just right, holding us gently, allowing birds to soar and kites to dance. The temperature changes within this layer create the winds, from gentle zephyrs to cleansing storms, all part of the planet's breathing, circulating warmth and moisture. The troposphere holds the vast majority of the atmosphere's mass and almost all its water vapor. It's thick enough to scatter sunlight, creating the beautiful blue sky we see during the day and the fiery colors of sunrise and sunset, gentle transitions between light and darkness. This layer is our life support system, the immediate source of the oxygen we need, the medium for sound that carries lullabies and whispers. It moderates temperatures, preventing the extreme heat and cold found elsewhere in the solar system. It's the cozy, familiar part of the hug, the part we interact with constantly, often without even thinking about it. It's the feeling of the air on your skin, the sound of the wind sighing through trees, the taste of fresh air after a shower. It's the ultimate comfort, the layer that directly cradles life. So, as you lie here, ready for sleep, Feel these layers wrapping around our Earth, around you. From the wispy exosphere brushing against the edge of space, through the heat-absorbing thermosphere with its dancing lights, the meteor-shielding mesosphere, the sun-filtering stratosphere, down to the life-sustaining troposphere that holds your breath. They all work together in a silent, perfect harmony. They form an incredibly effective, multi-layered shield, a gentle, unwavering hug that keeps our world safe and hospitable. This atmospheric embrace holds in the warmth needed for life, protecting us from the freezing vacuum of space. It shields us from harmful radiation pouring from the sun and distant cosmic events. It burns up incoming debris from space. It provides the very air we breathe, the water that falls as rain, the weather patterns that shape our world in cycles of growth and renewal. It's a constant, nurturing presence, a planetary-scale comfort blanket tucked carefully around us. Let the awareness of this incredible, protective embrace soothe you. Feel the immense peace that comes from knowing you are held safely within these layers. The vast, cold emptiness of space is out there, but here, within Earth's gentle hug, you are sheltered. You are secure. The sounds of the night, the gentle rhythm of your own breathing, are all happening within this safe haven. Allow the knowledge of this silent, tireless protection to deepen your sense of calm. Let go of any lingering worries, knowing that the Earth itself, through its amazing atmosphere, is holding you. Close your eyes and drift off to sleep, cradled in the soft, secure, gentle hug of our planet's atmosphere, ready for peaceful dreams, safe and sound until the morning light, filtered and gentle, wakes you once more. Sweet dreams. And so, our journey through the sky, layer by gentle layer, comes to a soft landing in the quiet of the night. We've traveled far, haven't we? Right from the familiar ground, up through the air we breathe without even thinking. That busy, weather-filled troposphere holding all the clouds and winds, wrapping around us like the softest quilt. We imagined floating higher, feeling the world spread out below as the air grew crisp and thin, passing that invisible boundary into the deep, settled calm of the stratosphere. We pictured the ozone layer there, a silent guardian high above, diligently filtering the sunlight, keeping us safe in its unseen embrace. A hidden shield woven into the peaceful blue. Higher still, our thoughts drifted into the mesosphere, a place reaching towards the edge of space, yet where tiny visitors from afar, little bits of cosmic dust and rock, blaze brightly as shooting stars. Meteors making their fleeting wishes known, burning up in a final, protective flash against the incredibly thin air, reminding us that even stillness holds swift, silent events. It felt colder there in our imagination, a profound, deep chill in the near emptiness. Then, pushing ever upward in our minds, we reached the thermosphere. It sounds warm, but it's a place of such sparse air that heat means energetic, dancing particles, gifted energy by the sun. These dances create the magical auroras, those shimmering, colorful curtains of light that grace the skies near the Earth's poles. And it's here, in this vast, quiet realm, that satellites glide on their orbital paths, our watchful eyes and listening ears in space, whispering messages back down to the sleeping world below. Imagine them now, tiny lights tracing silent arcs across the velvet darkness. Finally, we brushed against the very fringes, the exosphere, the atmosphere's final, gentle sigh, where the lightest gases, hydrogen and helium, drift off atom by atom, slowly, almost imperceptibly merging with the endless ocean of space. It isn't a sharp ending, more like a shoreline where the ocean of air meets the vast sea of the cosmos. And even beyond this, Earth's presence is felt, its magnetic field reaching out like invisible arms into the solar wind, a subtle reminder of home extending far into the void. Think of all those layers now, resting one upon the other, each unique, yet all interwoven, part of the same vital shield, the same life-sustaining envelope around our precious world. From the gentle breeze you might feel if a window is open, a stirring in the troposphere, to the unseen protection of the ozone layer, to the distant, ethereal glow of an aurora, it's all part of one magnificent, intricate system. A system that makes our Earth a vibrant, living planet, a cozy haven floating in the immense quiet of space. Now, as you lie here, ready for sleep, feel the gentle rhythm of your own breath. That soft inhale and exhale connects you directly to the troposphere, the layer closest to home, the layer that sustains all the life we know. Even as you drift towards dreams, you are breathing in a part of this grand atmospheric structure, sharing the air with trees and birds and clouds. The sky above, stretching out into the darkness, isn't just emptiness. It's a deep, complex tapestry, woven with currents, shields, and quiet marvels we've only just begun to understand. Let your mind float freely now, like one of those tiny atoms escaping the exosphere, drifting peacefully into the soft expanse of your dreams. Perhaps you'll soar through sunlit clouds, or watch a meteor paint a silver streak across the mesosphere's deep canvas, or maybe even join the satellites in their silent thermospheric ballet, gazing down at the slumbering continents and sparkling city lights. The universe holds endless wonders, from the air you breathe to the farthest star, glimpsed only by powerful telescopes, waiting patiently in the quiet dark. Sleep deeply now, nestled within the invisible embrace of the troposphere, watched over by all the layers stretching far above. Let the quiet stillness of the stratosphere, the distant mystery of the mesosphere, the energetic dance of the thermosphere, and the gentle fade of the exosphere into the great beyond lull you into a peaceful, restorative rest. The atmosphere, our planet's gentle breath, will be here when you wake, holding its secrets and its beauty, ready for a new day, filled with sunlight filtered perfectly through its many levels. Close your eyes and drift away now, carried on the soft currents of sleep, up through the quiet, starlit layers of the night. Rest well,